Hi everyone, we are from Group 2. We would like to present about the topic of Bayesian decision theories. My name is Lin Ziqi. I would like to introduce the fundamental concept in probability theory known as Bayesian theorem. Bayesian theorem describes the probability of occurrence of an event related to any conditions. It is also considered of the case of conditional probability. This is the expression of Bayesian theorem. Probability A given B is the conditional probability of event A occurring given that B is true. Probability B given A is the conditional probability of event B occurring given that A is true. Probability A and probability B are the probabilities of A and B occurring independently of one another. Bayes' theorem involves three key concepts, which is posterior probability, likelihood, and priors probability. Priors, these are these are our initial belief or probabilities before considering any evidence. Likelihood is represent the probability of observing evidence given that a hypothesis or event is true. Posterior probability, this is the update probability of an event occurring after taking new evidence into account. Now let's explore some practical application of Bayes' theorem. The first one is the medical diagnosis. Bayes' theorem computes the likelihood of a disease given symptoms or test result, assisting doctor in determining illness probability based on past experience. Next, the practical application of Bayesian theorem is signal processing. Bayes' Bayes' theorem estimates a moving object's position from noisy sensors input, updating belief with new data for robust predictions. That's all from me. Thank you.
Thank you, Ziqi. My name is Dong Xing, and I will discuss the statistic pattern recognition using Bayes' theorem. For the step 1, data collection. First, we need to gather relevant data. This could be image for image recognition or speech sample for speech recognition. The key is to have a good data set that represents what we want to recognize. Step 2 is feature extraction. Next, we identify the key feature in the data. For example, in image recognition, we might look at shape, color, or texture. The feature helps us to distinguish between different categories. And next step, step 3, model building with Bayes' theorem. We use Bayes' theorem to build a statistic model. This model calculates the probability of an object belonging to a certain category based on the observed feature. And the last step is classification. Finally, we apply the model to new data for classification. The model calculates probabilities using Bayes' theorem and make decisions based on this probability. Next, the real-world application. Let's look at some real-world application for the statistic pattern recognition using Bayes' theorem. The first is the image recognition, classifying objects in image, like determining if an image contains a cat or a dog. Next, speech recognition, converting spoken word to text, enabling virtual assistant to understand command. And the last one is text classification, categorizing text data such as identifying spam email or sentiment analysis in social media posts. That's all for me. Thank you.
I'm Li Jian. Now I will talk about the roles of Bayes' theorems. Bayes' theorems provide a principal framework for updating the probability of a hypothesis given new evidence. In pattern recognitions, this evidence often comes in the form of observed data or features associated with a particular instance. Bayes' theorems in pattern recognitions is in building classifiers. A classifier is a model that assigns classes labels to instances based on their observed features. Bayes classifiers, such as naive Bayes, utilize the Bayes theorems to estimate the conditional probability of each class given the observed features. Next, I will talk about the principle of application Bayes theorems. The first one is naive Bayes classifiers. The naive Bayes classifiers is based on Bayes theorems, which calculates the probability of hypothesis given the observed data. It assumes that features are conditionally independent given the class labels, which simplifies the calculations of posterior probability. Next is Gaussian mixture model. A Gaussian mixture model represents the probability distribution of data points as a wave sum of Gaussian distributions. Each Gaussian components represent the clusters in the data, and the models aims to estimate the parameters of these Gaussian distributions. So that's all for my part. I'll pass to the next presenter.
Hi, I'm Daniel. We'll delve into the evaluation and optimization of pattern recognition system. Let's start with how to evaluate the performance of this system. It is use metrics like accuracy, precision, recall, and F1 score. Accuracy measures the overall correctness of the system prediction. It is calculated as the ratio of correctly classified instance to the total instance. Precision focus on the positive class and measure the ratio of correctly classified positive instance to all instances classified as positive. Then recall measure the system ability to correctly identify a positive instance from all actual positive instances. The F1 score is the harmonic means of precision and recall, providing a balanced measure of the model's performance. Now let's discuss how to optimize pattern recognition system for better performance. Start by identifying and choose the most relevant features from the data to reduce noise and focus on important patterns. Then, model tuning involves fine-tuning the parameter of the pattern recognition model to optimize its performance. Data pre-processing is crucial. It involves cleaning the data, handling missing value, scaling features, and encoding categorical variables. Then, choosing the most suitable algorithm or combination of algorithms based on the data and tasks is essential for optimal performance. A simple technique like bagging, boosting, and stacking can improve the system accuracy by combining multiple models. Finally, techniques like K-fold cross-validation help assess the model performance accurately and will avoid overfitting. That's all for my part. Thank you.